In the lesson 6.1 example, how long will we be doing the homework? We're going to look at evaluating a claim. At the beginning of a class, Mrs. Chavez shows her class a box filled with black and white beads, and her claim is that the proportion of black beads in the box is 50%. That means half are black and half are white. So to determine the number of homework problems she's going to assign that evening, she invites a student to select a simple random sample of 30 beads from the box. And the number of black beads selected will be the number of homework exercises that the students have to do. So they could do as many as 30 if all of them were black, and they could do as few as none if none of them were black. In this particular case, when the student selects their sample, they ended up with 19 black beads. And the students are very upset at this, and they suggest that, oh, Mrs. Chavez, you don't have 50% black beads. Your box contains more than 50% black beads, because the 19 out of 30 is 63%. How could that have possibly arisen from, if the box really contained 50% black beads? And so what we want to do in this problem is we want to first determine whether it's possible or impossible that Mrs. Chavez's box of beads contains 50% black beads. So to determine if a sample of p hat, the sample proportion from this simple random sample of 30, if that is convincing that Mrs. Chavez was cheating, the class simulated 100 simple random samples of size 30, assuming that she was telling the truth, which means that they found some way to guarantee that they had 50% black beads. And for each sample, they recorded the sample proportion of black beads, and it looks like this. So what we want to do in this problem is in part A, it says that there's one dot on the graph at p hat equals 0.77. And we want to know what this actually indicates. So we're talking about this dot right here. So these are the sample proportion of black beads. And remember, each dot on the dot plot indicates the sample proportion from one of the samples. And so we can say that in one of the 100 simple random samples, 77%, which corresponds to 23 of the 30 that student selected, those beads were black in that sample. But only in that one sample. Most of the time, the sample proportion was closer to 1/2. In part B of this problem, we want to know if it would be unusual to get a sample proportion of 63% or higher in a sample of 30 when the true proportion of black beads is 50%. Well, we're looking at this grouping here. The reason we're looking at this group here is because all of these dots correspond to samples where the sample proportion was at least 63%. And so we can identify that there are 9 of the 100 simple random samples that resulted in sample proportions of 0.63 or higher. 9% is not all that unlikely. It's entirely plausible that a sample proportion this high could have occurred by chance. In part C of this problem, we want to know if there's convincing evidence that Mrs. Chavez lied about the contents of the box. Well, given that a sample proportion of 63% or higher is plausible, we're not going to say that there's evidence that she cheated here. It's plausible that the proportion of black beads in the box really is 50% and that the students got a sample proportion of 63% just by chance. Our results from part B indicate that something like that is entirely possible. If you'd like to try an exercise like this in your textbook, you can try exercise 9 in this section.